together. So anything that we struggled with before is going to come back to haunt us now if we haven't figured out what we're doing. Okay, so we have this question here: sine 2x plus sine x is equal to 0. It says solve each equation algebraically over the domain 0 to 2 pi. All right, now I have a double angle to single angle identity. I can't solve a double with a single, so I'm going to need to change that double to a single. So what is the identity for sine 2x?
2 sine A cos x, or 2 sine x cos x.
That's right. So I have 2 sine x cos x plus sine x is equal to 0. Now at this point, I need to try and get it into a times b is equal to 0, the zero product rule. So can I factor this? What can I factor out of here?
Sine x.
All right, so I take the sine x out, and I'm left with 2 cos x minus 1, or plus 1, sorry, equals 0. Sine x is equal to 0. 2 cos x add 1 is equal to 0. Cos x is equal to negative 1/2. All right, let's list all of the places that all of this occurs. Okay, where, and again, the domain is between 0 less than or equal to x less than 2 pi. So where does sine x equal 0 on your unit circle?
0 and pi, or is it 1?
Pi. Yeah.
You want us to always work in radians?
The domain is given
Oh,
as
the
0
domain,
less than or equal
okay.
to x less than 2 pi.
Mhm.
Okay, so that takes care of the sine x equaling 0. Where does cos x equal negative 1/2? Okay, well done. There's your 4 answers. All right. Again, you don't get that unit circle on the exam, but what you'll do and when we lead up to the exam is we will practice it. And the first thing that we do before we start the exam is actually put the first quadrant down. Okay, and then you can work off the first quadrant. So once you've got that, then it makes your life a lot simpler. All right, okay, that's it. Okay, that ties in radians in grade 12. That ties in finding angles in grade 11. That ties in the trig identities in grade 12. That ties in the factoring that you do in grade 11. So it's tying everything together right now, and that's what we're trying to finalize here. Pull it all together, and here's where you're going to hit the end of it. Okay, so now I have 6 sine squared x is equal to cos x add 4. Okay. So again, I would get everything equal to 0, but I have an issue. What's the issue? Sorry? No, it's the sine squared and the cos. That's the problem I have with it. Okay? So the sine squared and the cos is the issue. I need to work either in sine or cos. I don't want to work in both. There's only one circumstance, one question in which I would work in both of them. Okay? So can we change sine squared x? Yeah, Madison?
Didn't we work with sine and cos in the last question though? Like sine x bracket 2 cos x plus
Yeah.
1?
Yeah,
Is
yeah.
that because it already equals 0?
The difference is because of the
Oh, the
squared.
square. Oh,
Yeah.
okay.
Okay, and Reese is right. Got off to a good start here. We changed that to 1 minus cos squared x. So now I have 6 minus 6 cos squared x minus cos x, subtract 4 is equal to 0. Now, at this point, 6 subtract 4 is 2. We can agree with that? Okay. And it's a plus 2. We're okay? Because I'm about to do 2 steps in one here. So I want you to see. I want to multiply everything by negative 1. All right? So I'm going to end up with 6 cos squared x plus cos x minus 2 equals 0. Okay, 6 subtract 4 is plus 2, but I'm going to change it to a negative 2. You okay? All right, now I got to factor this guy. Okay, so I'm going to do it up here. I'm going to factor it. So I have 6x squared plus x minus 2. Product is 12, negative 12. Sum is plus 1. So my factors are negative 4, plus 4, and negative 3. Agreed? Okay, so that gives me 6x squared minus 3x plus 4x minus 2. 3x out, 2x minus 1 is 2, 2x minus 1, 3x, add 2, 2x minus 1. Okay. Is everybody okay with my factoring there? I did it quickly. I don't like working with the cos. If I do, I just change it to x for now. All right. So now what I have here is this. This factored out is 3 cos x add 2 times 2 cos x minus 1 equals 0. Therefore, cos x is equal to negative 2 over 3. Cos x is equal to 1/2. Questions? Everybody's okay with how I factored that? All right. Cos x equals half is on the unit circle. Whereabouts? Pi over 3 and? Very good. Okay. This guy's not on the unit circle. So we start with this and then the two quadrants that it's positive in, which is what? Oh, sorry, negative. My bad. Negative. Negative? 2 and 3. That's my bad. Its cos x is negative 2/3. Okay. So calculator's out. What mode should I have the calculator in? Radians. So I want it in radians. Let's find the reference angle first.
It's 2 divided by 3, not negative 2.
That's right.
0.841.
Okay. How do I get quadrant 2? Reese, how do you do quadrant 2? We just found this right here, the reference angle, right? I need that angle right there.
So, pi minus.
Yes, very good. So pi subtract 0.841, which is? Anybody?
2.301.
Okay. And then how do I get the third quadrant, Reese?
2 pi minus that angle.
No.
2.3.
I'm going from here to here, Reese. And there's my reference angle.
Pi plus.
Yes. Okay. Listen, when you're unsure of it, draw that thing out. And it'll help you make sense of it. Okay, so pi plus 0.841 is what? 3.983. Thank you. There you have it. There's your 4 solutions. Okay. Again, the only thing that we added to this that we didn't do in the last chapter was this identity. We somewhere have to fit one identity in usually in order to solve this. Okay? Follow so far. All right, so all of this, and this is where our struggle was. If you recall, we didn't do a good job of this on the test, and we didn't do a good job on the assessment, on the assignment, was doing this part right here. So again, we are building, and now we are hitting the end of this. All right, we have kept adding a piece to it. This is the only piece that we added to this that you shouldn't or haven't already done. It's just doing a substitution of a trig identity. Okay? All right, the next one is sine squared x equals tan x cos x. Okay, now this one's done over 0 to 360. This one has non-permissible values. Okay, so I'm going to change this right now to sine squared x equals sine x over cos x times cos x, like this. Okay, what's my non-permissible value? Sine x cannot equal 0. X cannot equal. We are in degrees here. Oh, sorry, cos x. My bad. Thank you. Cos x can't equal 0. So where does cos equal 0 on the unit circle? In degrees. Okay, so my solution cannot have 90 or 270 in it. Perfect. Okay, now I cancel those two. I end up with sine squared x minus sine x is equal to 0. What do I do next? No, because that's sine x isn't a perfect square.
Do you have to change the identity of sine squared?
No. Don't overthink the question. I already did my identity. My identity was sine over, yeah. My identity was sine over cos, correct? That was the identity part of it. So now what am I doing? Factoring.
Sine x is
So I have sine x
sine x
minus 1 equals 0. So we're sine x equals 0 and sine x is equal to 1. X is equal to. All right, where does sine x equal 0 on your unit circle?
90. No, 0.
0 degrees,
180 and 360.
180 degrees. I don't put 360 in because it doesn't say less than or equal to. That's okay. I want to point that out to you so that you do not lose a part mark on that. Okay? It says that it's not equal to 360, so we don't add that in as part of our answer. All right? That was where sine x equals 0. Where does sine x equal 1? 90 degrees. 270 is negative 1. Okay. Point to it. It's a non-permissible. So what do? X that out.
You still want us to write it down and then do
Yes,
like the
absolutely.
Okay.
100%, yes. We do need to see that it was part of the solution and then that it's part of the solution and then it's a non-permissible. You identified that. Excellent. Good so far, everybody? Okay, again, only addition to what we have already done is that root 3 cos x minus 1. Okay. I've got a double angle with a single angle. So the other thing too is I can't work with squares and singles, right? So, but that one's usually leads to factoring. But in this case, I can't use a double with a single, so I need to change the double to a single. Which equation are you going to use for cos 2x now and why?
2 cos squared x and cos 1.
And how come you chose that one?
Because there's a grid value.
Exactly. Okay, so I've got 2 cos squared x minus 1 equals root 3 cos x subtract 1. Flip it over to here. 2 cos squared x minus root 3 cos x equals 0. When I add 1 to both sides, those cancel out. Okay? Now what? Take out a cos. Cos x. 2 cos x minus root 3 equals 0. Cos x equals 0. Cos x equals root 3 over 2. This right here, this is a style of question that will be in the non-calculator part of the exam because it's not necessary that you use it. That last question that we did here, or 2 questions ago, this guy, that's going to be in the calculator part of the exam. That's in the first 5 questions. And more than likely, you'll see that in the first 5 questions of every exam will be in a question like this. Okay?
So it's gonna have like the identity in there too.
It probably will have an identity in it as well. Not necessarily, but it probably will. One of the 2. If they do it in the first part, they won't do it in the second. If they do it in the second, they won't do it in the first. Okay? All right. So where does cos x equals 0? And we are talking general solutions in radians now. Okay. Where does cos x equals 0? What is it? 90 and 270, right? Radians. Right. So pi over 2. I want you to watch how I do this. 3 pi over 2. Okay. What about root 3 over 2? Where does it equal? Pi over 6. And
Or not 11
11 pi over 6.
I really don't get the pi stuff. Like I just can't remember the units. Like I get it, but I don't get it.
Okay.
Times 6 to get 180, and then whatever you times that by to get 180, you times the 11 by 180, and that gives you your answer.
Oh, okay.
Okay. Now, because it's in rate and it's asking for general solution, what do I have to do to each of these? Right. Add 2k pi, where k is an integer. We do it to all 4 of them. I could have done one of them different, but I think for your benefit, I just write them all out for once around the circle and then add 2k pi to all of them is your easiest way to do this question. Okay, now I want to go back to Madison. The pi part's causing you grief. Here's what I do. I find my answer. In degrees. So it was 90 degrees. I times that answer by pi over 180 degrees. Because that's how I convert. 1 pi is 180 degrees, right?
Mm-hmm.
Well, what's 90 over 180 as a fraction?
1 over 2.
1 over 2.
So that's pi over 2. Okay, I think just where it gets me is when it's not like
Pi's?
well, like
Yeah, okay, so here's the other one. You saw that it was 30 degrees. Three 1/18 reduced.
1 over 6.
1 over 6.
Okay. Yeah, I can't remember like
So
the pi's with the root 3 over 2. But I remember.
right. So then if you can remember it in degrees,
Just convert it.
then convert it after. Yep. Do the whole question in degrees, but make sure you finish it off in radians like this.
No.
Okay. This one I could have done different. What could I have done here rather than go both of these in 2k pi? Any idea? How many radians is it from pi over 2 to 3 pi over 2? Just 1 pi, right? So I could have done pi over 2 plus pi, k pi, and that would have hit them all the way around. But I think it's easier to list all 4 of them and add 2k pi to it every time, and then you don't have to remember anything else at that point. Okay? Again, you're looking at 6 to 8 marks on your exam on these questions here. There'll be 2 questions on the exam on it. That's what you have to look for. Okay? I think the reciprocal one doesn't change anything. Do you want me to do the reciprocal one? Okay. You don't want it, Reese? You can start working. Okay, so I've got 2 cosecant squared plus cosecant. So I have this 2 cosecant squared. It's theta plus cosecant theta. Oh, they're x's.
So if it's, I can't remember the difference between theta and x.
Nothing.
It's nothing.
Nothing. They're the same thing.
Oh.
Okay, so now this factored is 2 cosecant x minus 1 cosecant x minus 1 equals 0, or sorry, plus 1. Yeah. Okay. All right. So in this guy, I get cosecant x equals. What does cosecant x equal in the first one?
Negative half.
Not negative.
Oh, half.
1/2. That's right. Okay. And then cosecant x is equal to what here?
Negative 1.
Negative 1. Now, this is where we messed up on the last section. We don't want to mess this up. Flip both sides. Flip both sides. This becomes sine x equals 2. This becomes sine x equals negative 1. Do we follow that? Cosecant is 1 over sine, so I flip it. And whatever I do to the left, I got to flip the right side as well. Got to there? Okay, where does sine x equal 2?
So I'll leave it so
It's not on the unit circle. So what do? It's not on the unit circle.
find the reference angle.
Okay, find the reference angle for sine x equals 2.
No, because it has to be less than 1, doesn't it?
Yes, it does. No solution for that. Remember, what's your amplitude for a y equals sine x graph? 1. The highest it can go is 1. The lowest it can go is negative 1, correct? Yeah? Okay. So then if sine x is equal to 2, it can't be a part of the solution. It has to be between negative 1 and 1. All right. Now, where does sine x equal negative 1?
3 pi over 2.
3 pi over 2. And it asks for general solution. So what do I add to this guy?
2k pi.
Yeah. Where k is an integer. Excellent. There you go. Done. Okay. We good? All right. Okay. Big section. Guaranteed marks on the exam. We have to focus on this section. So I need you to go through that today and get it done. Fair enough? Okay. Have a quick look at yesterday. See if there's anything I can do for you yesterday.
Can we do 3c on 209? I got like halfway through.
These come down to express the rational expression is a single term. Okay, cosine x, or cos x, over 1 plus sine x, right? Add sine x over cos x. Sine x over cos x. Okay, what did you do first?
I changed, oh no, I didn't. I just did cos x times cos x to like make it common denominator.
Okay,
on both
good enough,
sides.
I got you.
Yeah.
Cos squared x plus 1 add sine squared x, and all of that is over 1 plus sine x cos x. Yes, I got to there too. All right. What'd you do next?
I stopped after this one because the bell rang cost.
That's like a close,
No, can't because of the add signs,
but not even the square.
not even the squared. But you're not far off what I would do. Okay. Because of the add signs, I can't cancel those. So what I'm going to do here,
Can you change the cos squared x to 1 minus sine squared x?
you want to do it that way?
Like, does it make sense? Is it easy?
It does make sense, and it
It'll
would
make
be
it
a longer, it would be a longer way to go. Change the cos squared change the sine squared to cos squared.
Oh, okay.
Let's try that, okay? So let's do this. Let's go oops, can't write today. Cos squared x, whoops, add 1, add 1 minus cos squared x here. I'd end up like this. And then I got 1 plus sine x. Just gonna leave this as is on the bottom, cos x on the bottom. That. Okay. So what does that leave me with on top?
Can you change the 1 and sine squared x to negative cos x? Or negative cos squared x?
Here?
Yeah.
Change to what?
Negative cos squared x.
1 minus cos squared x. Has to be 1 minus cos squared x.
Is it just 2 on the top?
Yeah.
You could have done that from the beginning, because cos squared x plus sine squared x equals 1. So 1 plus 1 equals 2.
Right here?
Yeah.
Yeah, I agree with you. I agree with you.
Oh, so we made it even longer than that.
Which is okay. Like we're learning that. So yeah, I agree with you. So essentially what I have here, rather than doing that, okay, but I got to figure out where to go at this point. This is what I have here now. Where do I go at this point?
I just, because like wouldn't 1 times sine x equal sine x? You get like x squared x.
Where are you?
Like still at like the beginning, like,
Yeah.
because I go this.
Oh, I got a problem here. My bad. I made an error here,
Yeah.
and I just saw it as you pointed it out. This should have been sine x here.
Okay, that's what I had, and then I
Okay.
erased it when
Okay.
you were with me.
Now I do what you do. Yes. Okay. Good job. Okay. Now I do that. I like what you did there. So now I have this 1 minus sine squared x. I change that, right? And then I have plus sine x, add sine squared x on top. Good. Over 1 plus sine x cos x. Like this. Okay, great. We're gaining. Okay, so my sine squareds cancel, do they not? Like that. Red for canceling.
Isn't it like the same thing that you could just do?
No, just wait. Now, What do I have on top? What am I left with? Yeah,
I'll just do that. Plus square x plus sin x.
just a second, just a second. We'll come back to it. Okay, now what? Cancel that with that, right? What am I left with? 1 over cos, which is? There's my final solution. Okay, now you talk to me where you're at.
Like you could just skip like the second step, I guess. If you can, like from the cos squared x plus sine squared x, just move to directly to 1 plus sine x. You don't have to do that.
Where are you
Like,
pointing?
it would be-
Oh, yeah, I see what you did. Okay, yeah.
Wait, can you
Okay.
just write it again?
Yeah, I got you. I'll show you. I'll show you exactly what she's doing. She's absolutely right. I love it. And then the thing is, can you identify that Pythagorean theorem and that Pythagorean identity? All right. Right here, Madison, cos squared x plus sine squared x is actually what?
1.
So I could have just wrote 1
So
plus
just
sine x.
Oh, okay, yeah.
Okay. So what we're learning about this, which is fantastic, okay, is we can go through it. It can be complicated. But if you recognize something as simple as that sine squared plus cos squared, it's a 2-step question. It makes it a lot simpler. Okay, and we didn't do it twice. Twice we didn't do that. But yeah, right here, well done. If you see this and this, you change that to 1 plus, or 1 equals to 1, and then add sine x. That's awesome. Okay. And again, the more you do, the better that becomes. You get a little bit. You start to see the patterns that they show you. All right. Anything else out of that bit there?
I actually only got the 3 students.
Okay. All right. What I'd like you to do, I'd like you to go to today's work and then go back eventually and do I would suggest you do as many of those proofs as you can just to get good at it.
So like
But-
before we do the review last week, just like finish
Yeah.
2.3.
I think it would be in your best interest.
Okay.
Okay. There will be 1 proof on the exam. There might be 1 or 2 on the test, but there'll be 1 proof on the exam for sure. Okay. No other questions then?